For the next 2 weeks, we're going to be working on tests of association, and specifically, we're going to focus on correlation and regression. You need to remember your types of data, NOR, nominal, ordinal, interval, and ratio. And you're also going to want to look back on quantitative research, specifically looking at surveys and experiments, and theory and variables. One good way to think of correlation is to look at a Venn diagram. So these are 4 ways that people get on social media. So they could use a wiki, they could have a blog, they could participate on a forum, and they could also do Dig or Reddit. And so what you see is that people who participate on wikis overlap with people who participate on Reddit. People who participate on Reddit overlap with people who participate on forums. And then people who participate on forums overlap with some of the people who participate on blogs. And then in the very center, you'll see are people who participate on all of these 4 forums. So the types of people who participate on forums are related to the types of people who participate on blogs and so on. So this is how you might see an example of a correlation. When we use the language of correlation, we are talking about relationships. So an example research question would always say something like, does an increase in Y correlate with an increase in X? So an example would be, does the amount of public speaking practice time decrease public speaking anxiety? So we're asking, do the more you practice, do the less you feel anxious? An example hypothesis could be an increase in X is negatively correlated with an increase in Y. So an example would be an increase in public speaking time will negatively correlate with public speaking anxiety. And negatively correlating is simply another way of saying when one goes up, the other one will go down. So correlation is essentially a test of a relationship. Does a relationship exist? So you can have a positive correlation or a positive relationship when variable X goes up, variable Y goes up, or you could have a negative relationship when variable X increases, then variable Y decreases. No correlation or relationship means that when variable X does anything, go up or go down, Y remains unchanged. So here is a graphical representation of the different types of correlations. So we have here negative, 0, or none, and positive. So on the very left, you have a negative or inverse correlation. So as the mileage of your vehicle increases, then the value decreases. So the more you drive your car, the less value you have, right? But as auto value, you can see at the bottom, as auto value is increasing, that's because you have less and less and less mileage. Auto quality and auto body color are not related at all. And then in the last frame, you have a positive correlation. So as auto accidents increase, your insurance cost also increases, right? And these are linear relationships. So in other words, the correlations occur in a line. You have negative or inverse, and positive are lines. For the 0, we can't find a line. So here's another sort of set of examples. Age and height. So as you grow older, you get taller, right? Up to a certain point, right? So you're taller at 2 than you were at 1. You're taller at 20 than you were at 11 for most of us. So that is a positive relationship. When one goes up, the other goes up. A negative or inverse relationship is when one goes up, the other goes down. So as heat decreases, the number of people ice skating increases, right? So heat is related to use of outdoor sports. So when heat goes down, outdoor sports, such as ice skating, go up. An example of no relationship would be the amount of salmon you eat and how much you like the color red. So there really shouldn't be any relationship to the intensity in which you like the color red and the amount of salmon that you consume per week. When scientists get into trouble or when people misunderstand information, it's often because we are assuming that because we have established that a relationship exists, that it means that there's causation. And that is not the case. In fact, we talked about this all semester long, but here's where it sort of rubber meets the road. Correlation is not causation. So in other words, we could treat both variables as independent because we don't really know when or if one variable comes before the other. So if we may use the results of a correlation to do other types of testing, but it by itself is not a causal claim. But the way we think about information as human beings and the way that we interpret information that we're given as human beings often leads us to assume causal relationships. So here's sort of an extended example of why correlation is not causation. So if we look back at communication apprehension, we can sort of see two different ways that communication apprehension could affect what's going on in the body. So the first thing it does is influence the fight or flight response. So you get a feeling of anxiety, and then your body begins producing cortisol, and your heart rate increases because you feel like you're getting ready to do some sort of physical movement, whether it's run or fight, and your heart begins pumping faster to deliver more oxygen to your muscles. And because your heart's beating faster, you begin producing sweat. And because you have adrenaline and cortisol running through your body, sometimes you get shaky limbs. So this is all happening as a response to an anxiety stimulus that your body is interpreting. On the other side, you have thoughts, so cognitions, that are causing you to feel anxious, like self-doubt. And because your brain is racing, you can sometimes have halting speech. So these are two different ways, they can occur simultaneously, that your body is reacting to this communication apprehension. You will find a correlation between heart rate when someone is experiencing communication apprehension and possibly halting speech, because a person who experiences one reaction is likely to experience another. But the fact that your heart is racing is not causing your speech to be halted. So there is a correlation because there is an underlying process that's occurring that's related. But it's not, one is not causing the other. They are both related to something more fundamental. And this is most often what's occurring when we establish a correlation. We're finding that one thing is related to another because they're both related to an underlying phenomenon, not because one is actually causing the other to occur.